Hi everyone. Today I'm going to go over the legal problem, construct binary tree from preorder and in-order traversal. So first, let's do the question. Given two integer arrays, preorder and in-order, where preorder is the preorder traversal of a binary tree and in-order is the in-order traversal of the same tree, construct and return the binary tree. So before we get started, I just want to go over what in-order and preorder traversals are. So in-order means you traverse a tree left, root, right. And preorder means you traverse the tree root, left, right. So let's take a look at this example. So here, right, we're given both the preorder and in-order, and the one has to come up with the original binary tree. So here, let me just write down the inputs. So the preorder array is 3, 9, 20, 15, 7. And the in-order array is 9, 3, 15, 27. So let me just write this down. So preorder is root, left, right. And in-order is left, root, right. Okay, so from the preorder array, we know one very important thing. The first element is always going to be the root. So we know that the root of the binary tree, in this case, will be 3. And what we can do with this is we can take this value and find the index of this in the in-order list. So find the index of 3 in the in-order list. And the reason why we want to do this is so that we can split up the in-order list into two parts, a left subtree and a right subtree. So in this case, the left subtree will be 9. So the left subtree is everything that's before this element. So the left subtree is everything that's before the index of the root that we were looking for. So in this case, like 3 is our root, right? So we first find the index of 3 in the in-order list, and based on that index, right, anything before the index is the left subtree. Anything after the index is the right subtree. So right subtree. And we can just do this recursively. You know, like next step, it'll be 9. We'll see if 9, we'll try to find 9 in both like the left subtree and the right subtree. And whichever one we find it, we'll try to break it up. Again, it's like another left subtree and another right subtree, and so on and so forth. So basically, the idea is, just to recap, from the preorder, we can find the root. We take that root, and we find the index of that root in the in-order list. And then based on that index, we split up the in-order list into two lists, a left subtree and a right subtree. The left subtree consists of all the elements that is before the root, and the right subtree consists of all the elements after the root. And again, we have the index of the root, right? So it'll just be some index manipulation, and then we just keep doing this recursively until you know, like there's no more. So let's go to code now, and let me do this code. So we're going to find the index so here, right, so what I'm doing, here is that here I'm finding the first element of the preorder array. We know that's the root because that's how preorder works, right? It's root left, right. I'm popping that, and I'm finding the index of that element in the in-order list. So here I'm creating like the tree node, the tree node for the element we just popped, basically the root. And here we're gonna get its left and right children if there are any. Let me just copy this. And here we're gonna pass in a preorder. Oops. I'm gonna pass in preorder, and we're also going to pass in order, but again with some index manipulation. So like I mentioned before, right? Anything, so like all elements to the left of the root element that we found in root in the in-order list, that's part of the left subtree. And we have a similar thing for the right subtree. So let's change this. Right. So anything after the index of the root in the in-order list, in-order array, will be part of the right subtree. And finally, we just return the root. So root. Let me just double check I didn't miss anything. So in-order. Yep, that looks good. Let me quickly do a test run. Okay, and let me submit this. And yeah, you can see this is a valid solution. Thank you all for watching. I hope you learned a lot.